Hello dudes, welcome back. This is the 5th tutorial in the JavaScript Jumpstart series, and we're going to be looking at maths to see what we can do with JavaScript. And we will also be working our way towards making a maths quiz program, which we'll be doing in just a moment. First of all, I just want to show you some of the basics with JavaScript, some of the things that we can do with numbers. So that's the basic code. If we now save that, I'll just open this window a little bit wider and I'll click save and we should get something on screen. So this is pretty much exactly what we've been doing for the last 4 tutorials, nothing new yet, and we're now going to look at the first little bit of maths that we can do with JavaScript. So let's create a new script. So now let's replace line 1 with some mathematical calculations. We just need to get the elements object by using getElementID, just like we've been doing before. So I'll just do that now. So that gives us the object. And let's just type a sum in now so we can see some basic numeracy taking place on screen. And now when we run this, are you expecting to see 17.5? 5 times 2 plus 15 divided by 2 should be 17.5, don't you think? Let's click save now. It's because the 5 times 2 is being evaluated first on its own, being added on to the string, the inner HTML. And then after that, the 15 divided by 2 is being evaluated, and then that's being added on. So 5 times 2 is 10, so 10 gets added on to the string, and don't forget that's not then being treated as numerical. And then 15 divided by 2 is 7.5, and then that is added on to the string in string form. It just strings it together, and so we've got 107.5. Now we can get around that. We can force it to evaluate everything before it adds it to the string just by adding 2 extra brackets. So if I just add 2 extra brackets like I've just done here, then it should evaluate the entire sum and then add it onto the string, and we should get the correct answer. So I'm just going to click save now. And there we go, 17.5. That process is called string concatenation, where parts are added onto the string. And just in case you don't already know, this tutorial is going to include a maths quiz that we're going to program ourselves. The things I'm about to show you we will need to use in the maths quiz, so just bear with me a moment. I'll get some of these things on screen. So the random function of the maths object returns a number between 0 and just below 1, so from 0 to 0.99999. And because we want to work with a larger value, we'll just times that by 100. And there'll be 4 more paragraph lines that we're going to be modifying. Obviously you can see we've already modified line 1. We want to modify lines 2, 3, 4 and 5. So I'm just now setting up the 4 lines to modify those. So I'll just copy and paste. Again, this is something that we did in the first 4 tutorials. Nothing new yet going on. So the JavaScript toFixed function, we can call that on a variable name. So we've got random number, which is a numerical value because we've set random number to the return value from the random function, and we can call the toFixed function and specify the number of decimal places that we want that to be set to. So if I save this now, we should see line 2 change to display the random number multiplied by 100 and then restricted to 2 decimal places. So I'll just click save now, and there we go. We've got a random number after being multiplied by 100 is 21 point and then a whole load of decimal places, and then we restrict it to 2 decimal places, so we've got 21.16. Now if we want to look at what the number is without timesing it by 100, then obviously we can just delete and click save again now. If I keep clicking save now, we'll see that number changing. You can see it's never going above 1, it's never reaching 1, and theoretically it could be 0, but I think that's unlikely to happen. That's what's going on there. I'll just undo that and put that back and click save again. Now I'm going to show you something else very quickly. So what we're about to use is the math object. JavaScript has got a math object, and when we use dot notation, we can get access to all of the things that the math object is capable of. So let's have a look. Let's round the value. If we put the result of our random number after being multiplied by 100, if we put that result in here, let's see what that gives us. And there we can see it's rounded to 31. It rounds to the nearest integer. I'll just click save a few more times just so we can see some more results. So we've got it's rounding up from 82.63 rounding up to 83, 71.85 rounds up to 72. Let's get one to round down. 54.23 rounds down to 54, and so on. So if I click save now, we should see the result, and then I'll explain what it's doing. So I'm going to click save now, and we've got 47.63 is equal to 47. Math floor always rounds down to the nearest integer, so 47.63 is simply being rounded down to 47, as opposed to typically being rounded up to 48 like the round function. If we just change that to one more value just as a test, so we'll change that to 32, let's say 44, and click save. I'll change it in there as well just so it reads correctly, and I'm going to click save now, and there we go. So 32.44 is also being rounded down to 32. You'd get the same result with the round function, no doubt. Let's just have a look at the next one. And so we've now got math.ceil for ceiling. So let's click save, and we've got 33. You've probably guessed already, it's just doing exactly the opposite to math floor. So let's look at the next one. The math trunk, which stands for truncate, simply removes all of the decimal places, so we just get left with the integer part. When we save this now, we should see 12.97 change to just 12, so I'm going to click save now, and there we go. If we can change that to any value, obviously it's not going to make any difference, just like before. Click save, and we're still left with 12. Let's look at the next one. So the math function, you've probably guessed, returns the maximum value out of all the ones that we provide to it. We can see that it should be returning 92, so let's just click save now, and there we can see 92. Let's just change 92 to a lower value just to test it. So now it should be 73, so click save now. I'll leave the numbers the same. The mathmin function, no doubt you've guessed this one, is just going to return the minimum number. We're looking at 42, so let's just click save now. Let's change the minimum number. Let's increase that, and the next one in the list should be 46, so just click save now. There we go. So let's move on to the next one. The math sine function gives us the sine of the angle, but in radians by default. We're using math pi divided by 180 to convert to degrees, and so this should give us the sine of 30 degrees as we've got just there. I'm just going to click save now, and we've got I know that the answer to that should be 0.5, so let's try the next one now. 0.866. That looks correct to me. So let's move on to the next one. So the maths abs function, abs stands for absolute, makes any negative number become a positive value. I'm just going to click save now, and we can see that minus 33 becomes 33. If we change it to a positive number, it just doesn't do anything effectively. Click save, and 39 just becomes 39. And we can change that to a fractional value, negative 44.567. And let's click save on that. Let's move on to the next one. And the math power function raises the first number to the power of the second number. So 5 is raised to the power of 3. And the math square root function gives us the square root of the number in question. Now, the reason that I've been putting the break HTML after each line was because originally I wanted to show these all on screen at the same time, but I forgot to put the plus equal sign in. So if I just change all of these now, and now when I click save, let's see what it does. There we go. It's quite cool, isn't it? So apart from, that's not cool, is it? Let's get rid of that plus. There we go. So we've got all of the examples that we just looked at, and we can see them all on the screen at the same time. So now we're ready to do the maths quiz. So I'll program the first function, and then I'll go through that in considerable detail, explaining line by line exactly what is going on. I'll just quickly type that in now. If at any point you want to declare multiple variables of the same type, you can just separate them with a comma like I've just done there. So that's our first function, but if I click save at this point, I don't think anything is going to happen of any significance. So let's just click save now. And we can see that line 5 has changed to the text, but nothing else. We need to add the input field so that the user can type in their answer, and we also need to add a submit button, and while we're at it we may as well put a reload button in case the sum's too difficult or you just want to change the sum. Let's do that next. So if we now click save, we should see something appearing at the bottom of the screen just here on the right. And as we can see, but that doesn't look very neat at the moment. So let's add some more CSS to make that look a little bit larger. Let's set the font size to 25 pixels. And align the text to the center. And let's increase the size for the 2 buttons as well. And let's just widen this a little bit so we've got more room. And let's click save now. That's definitely looking better. So everything looks in place now. The function that we've just generated is this one here. And so the reload button is going to call that function if we want to create a new calculation, and the submit button is going to call a check answer function that we haven't yet created. That's all that's going on there, and then we've just got the input element that we've just added in as well, and obviously the text just immediately within the division that we've added. So let's go back down to our generate calculation function, and I'll go through that line by line. In fact, first of all, so I'm just going to click save first of all, just to see what happens out of curiosity. It's generating a new sum, and let's attempt to answer it and just see what happens there. 9 times 7. Too difficult. Reload. Reload works. So we click on the reload button and it calls the function again. Let's get to one that we can do. 1 times 4.3. But when we click submit, nothing happens, and that's because we haven't yet created the second function. But we need to understand the first one, so let me go through what we're doing with this first function. We're declaring a new variable and assigning it a random number. We're doing that in this line just here. And then we are, if you remember from the truncate just here, where we've got the 12.97 being... I didn't change the 12.97. Oh, that threw me then. 13.33. I'm going to click save again. So back to the math truncate function. If we keep clicking reload, we can see that we are getting a number. The first number, we can see we're getting anywhere between 0 and 9. We're pretty much seeing 0 to 9 appear there on the left. And that is coming because we are timesing the number, which is anywhere between 0 and 0.99999. We're timesing that by 10. We're truncating the decimal places, and that's what's giving us the 0 to 9 on the left of the multiplication sign. For random number 2, we are doing something very similar. We're timesing it by 10, but then rather than getting rid of all the decimal places, we are just using the toFix function like we used at the top just here, and keeping one of those decimal places, obviously just to make it a little bit more difficult. Now for line 5, we're doing nothing other than just changing the text with the inner HTML property of the element. That's pretty much the end of generate calculation, the first function. We've got to do the second function. At this point, just click save to make sure it's saved. Let's just attempt to answer, let's pick something a bit easier. 0 times 9.9. Even I know the answer to that one, so, and it's not 9. So 0, and click submit, and nothing happens, not surprisingly. At this point, I just want to open the DevTools window. So let's do that. And we've got the DevTools appearing on the right. We are on click, we've got an error straight away. That is because, let's just click save. The error's gone. So when we type a value, let's just change the size of this. When we type a value for our answer, let's just do any old value and click submit. We get the error because we haven't yet defined the second function. So let's create the second function. So that would seem to be enough. So let's just go through this second function before we click save. We've got another variable that we're declaring, user answer, and we're accessing the input element that we entered further up the page a moment ago. This input element just here, which is this box here where we're entering the answer into. So we are getting the value that the user enters into that box. Every time we click on the submit button, it calls the check answer function, and we get the value by accessing the value property of that element. Simple as that. That's the user answer, and the correct answer is obviously just number 1 times number 2. And so it seems like the only thing we should need to do is to check the user answer against the correct answer, and everything should be hunky-dory. But there's a bit of a catch coming up, and so there are literally a few twists and turns, and I'm going to quickly go through them. They are very important because it's about the way that the double equal sign and the 3 equal signs, the strict comparison operator, it's how they compare and what goes on when we start to compare integers with strings and things like that. Anyway, I'll show you the results as far as we've got so far. So I'm going to click save now, and we know now that it's going to do something when we submit the answer. Let's just push that button back on there. So 8 times 9.6, too difficult. 3 times 2.6, 7.8. No, dude. So let's... Is that true? 6, 1.8, 7.8. We know that there's something wrong there. So let's have a look at... Let's use console log to check the types within the check answer function. User answer, correct answer. Let's use console log just here. We can now click submit on that same answer. Because nothing's going to change unless we... no, because we need to resave the file. It'll give us a different number. There we go. Well, we know that's an easy one. So 9.3. Let's click submit. We can see that we've got the user answer. There we go. User answer 9.3 and the correct answer 9.3. And it's saying no. We haven't actually checked the type yet though. So let's add another console log line to check the type of each variable. And this is going to be good practice because then we can play around with it and we'll always know what we're dealing with. So again, once I click save, it's going to give us some different numbers. Just to explain what we're doing now, type of gives us the type. So whether it's a number type or a string, I need to put, that would have been misleading, wouldn't it? So there we go. Type of user answer and type of correct answer. So let's click save and see what we get. And let's 4.5. Easy peasy. Submit. And it's telling us that we've got a string and a number. So that's why it's giving us the wrong answer. Let's change the strict comparison operator to just the, I think it's called a loose comparison. I'm not sure. Let's click save. And let's answer this one. Naught. Submit. And it's telling us that we got that right. And it's comparing a string with a number. And it's telling us that it is correct. And so let's now, something I checked earlier I want to show you. We've got the correct answer coming up, and let's keep clicking reload and you'll see something that I was going on about earlier. We're going to display the correct answer every time we click the reload button. Let's just modify the first function slightly. Console log. I'll explain this in just a second. And now when we click save, we're going to see the value of each of the individual numbers, and we're also going to see the result of the sum displayed in the console window. Let's click save now. And we've got 0, 5.8, and the precision check, which is the answer to the sum, is 0. Let's just put that on one line. Now if I keep clicking on reload, we'll see that we've got different results coming up each time. Let's keep going. Boom. What have we got here? Number 1 is 3. Number 2 is 0.7. We know that the answer should be 2.1, but look at what the answer is. Don't forget, precision check is the answer. So 2.099. So we've got a precision rounding error there, and therefore if we were to type in the answer 2.1, let's submit 2.1, and it's saying no. Let's type in 2.0 and then fill, I don't know how many 9s are there. Let's just see what happens. No, so it doesn't seem that we can get the correct answer. I can't count. We'll see if we can copy and paste. We tricked it. So copy and pasting the value from the console window, and that's the answer that we gave, because I ending with a 6 there, and it's correct. But obviously that's not going to be good enough, so we can't rely. I'm just going to refresh the page and click reload again. There we go, look, keep clicking, and again 2 more occurrences. Look, there's a 1 on the end of this 4.8, and there is a 6 on the end of this 50.4. so every now and then it's going to tell us that we've got the wrong answer when we know that we've entered the right answer. We need to do something about that. And so what we can do is, because we know that the toFixed function rounds the number up or down correctly, and we know that the precision error is always going to be minuscule, so it's going to round it in the correct direction. Let's apply that function to the correct answer. And because we know that the answer is going to always be to 1 decimal place, let's just round it to 1 decimal place with this function. That should stop any occurrences now, so let's click save, and let's click on the reload again. See the precision check. Obviously I've just added the toFixed function onto the actual answer, not the precision check. So just to make that a little bit clearer, let's also add it onto the precision check. So we can do that by putting brackets around. Did that on its own? No, it never. Now try again. Keep on clicking reload. And there we go. Doesn't matter how long we carry on for, keep carrying on. Precision check is always now correct, which is great. Let's now answer another sum and see what happens. 1 times 6.6. Nice and easy. Awesome. And we are comparing. Click save again. Actually, I made a mistake there. I've correctly shown you how the toFixed function is fixing the precision check. I haven't actually. That makes no sense, does it? So that's better. So we've got correct answer equals correct answer toFixed, the same as for the precision check. So let's click save, and let's answer another sum. Now we can see that we're comparing 2 strings together. We're still getting the correct answer, which you might think is great, but there's a problem. Look at what happens if we just add a 0 onto our answer of 3.6. No, it's telling us we've got the wrong answer because it's comparing 2 strings, and 3.6 is obviously, you can see here, user answer 3.60 and correct answer 3.6. They're not the same. It's a string comparison, so it's not the same. How do we get around that? Now, I googled this earlier, and so we're looking at the toFixed function, and we can see that it returns a string. So that means that when we restrict it to 1 decimal place, just here, we are converting that to a string, and that's why it's no longer a number as it was before we used the toFixed function. So then that got me wondering about what happens in JavaScript when we multiply a string by a number, and so I googled that, and according to W3 Schools, it tells us JavaScript will convert the string to a number when doing the comparison. That means all we need to do is convert either one of the answers, the user answer or the correct answer, to a number, and it should be fixed. So we can, let's just do it to the one we just changed. We can use the parseFloat function. And now let's click save on that. and let's give an answer. We keep getting the easy ones. And now we can see that the correct type has been converted to a number. So let's add a 0 and click submit. And we've still got the right answer. But now we might be wondering, is there any way we can use the strict equals to operator? Let's just change it to strict now and click save and see what happens. And so that's made it worse. What are we going to do now? We started off with this operator and we changed to the other one that doesn't check for the type comparison. And now we're switching back and we've got the same problem. We now know that we were going to have to use the toFixed function because of the precision check error. So if we want to carry on using this operator, what do we need to do? We can just change our user input type from string to parse float, surely. So the user input type, that should fix it, surely. Let's click save and let's give an answer. Being brave taking this one on. 12.6. There we go, correct. And we can see that both types are now numbers. And let's just check this. There we go. Ooh. So yeah, everything's working great. Hopefully somebody's not going to tell me that I've missed something. It doesn't matter. It's all about experimenting and learning and doing things as we go along like this. So that's all cool stuff. This is the final tutorial, don't forget. This is the last one of the 5. If you've landed on this one and you haven't seen the other 4, go back and have a watch of those. Don't forget to subscribe. I'll be doing more stuff like this in the very near future. And thanks for watching, and I'll see you next time. Cheers.